Then you use the buffering tool, buffer tool. You can check its coverage. That's very useful. It can be used for static analysis. But integrate this, I want to point out, to integrate these ArcGIS tools to simulation tools is not that easy. So you see these functions have already been developed, but you cannot use them. And if you want to implement these functions in vSim, you have to write your own code. So that's a big problem of the simulation tools nowadays. I want you to be very cautious about this. Now let's go to homework 4, which was the project problem. I asked you to summarize one project you have ever done. And first, most of you picked a successful project. And I summarize those possible reasons to success. The first one is all group members handle their responsibilities in a timely fashion. That's good. The second thing is when they were designing the experiment, they used psychological knowledge. So the participants will follow the experiment and spend more time and work harder, review a lot of literature and help each other. These are the reasons of success I summarize. But let's take a look at what possible improvements you could make. A person said use CAD because in design they use the pencils, maybe pencils and rulers. Then maybe next time you can use CAD and set strict deadlines. Improve programming skill. Get help from authorities. This is for data collection. And this is for a research topic. He mentioned a small improvement could be a good idea. So you don't always need to find a big topic for research. A small improvement may be good. And define specific roles for each team member. Make a test before you make a decision. So if you have several alternatives, you may want to test your alternatives before you choose which one. And a group may involve less group members because when a group grows bigger, it will be difficult for them to communicate. And the last one is to keep the whole team updated more often. For example, if you and your team member are not located in the same office, you may want to have a regular meeting. So I summarize these answers. It will be interesting. Homework 5 was network coding using vSim and AIMSIM, and you are all doing it very well. So I skipped it. Here is homework 6, transims, coding transims. I want to mention that the plan file as the input of macro simulator must be sorted first. And if it's not sorted first, you are going to see a lot of problems, or some problems, like arrival time problem or departure time problem. So if you see a lot of those problems, be sure to sort it first. And in the package I gave you, there was one mistake. The plan preparation _sort tool is missing a key. So it doesn't sort the result. It doesn't solve the plan. And this was fixed in the second package I gave you. And that's why when you run my first case, you will see a lot of departure, not a lot, but like a certain % of departure or arrival time problem. And the second thing is somebody could not correctly spell transims. And this was not a typo, because I would identify the typo because all the occurrences of transims were transient. And this actually is a trademark of this company. So it was very surprising that somebody could not spell transims after I spent a whole lecture talking about transims. So I want to emphasize here, so you will know it. Next time, it's transims, not transient. Homework 7 and homework 8, they were all about, homework 7 is about shortest path. You have all done it very well. Homework 8 is is what is Transams DTA. I couldn't remember, but you have all done it very well. Now let's go to homework 9. Homework 9 is about the differences between those 3 feedback procedures. And I want to summarize the differences. The first difference is for each procedure is how they calculate delay, if they are using VDF, volume delay function, or microsimulator. That's the first difference. The second difference is that in each procedure, you will reroute some households. But is this a partial reroute or full reroute? That's the second question. And the criteria of selecting households for rerouting. So let me ask you a question. In the first, in the router stabilization process, is it partial reroute or full reroute? Can somebody answer? Partial, because every time you use criteria, you select some household and you reroute them. What about this? The second one, macro simulator stabilization. Is it partial or full? It's still partial because you only change the way you calculate the travel delay, link delay. But for the third one, for the user equilibrium, is it partial or full? It's a full reroute. Every time you reroute all the households, unless there is no difference. So the first 2 ones are partial reroute. Now I want to emphasize the elegant point. Let me give you some examples. This is first one. This is Jace. This is Jace. This is a good example. I just want to have a look at how it looks like. Now I will give you a normal example, an acceptable example. The name is hidden here, so you won't know who this guy or this girl is. It's acceptable comparing with Jace. It doesn't look very beautiful, but it's clear. Now I have a better example. In this example, I don't have to hide the name because it has no name. And you see, these paragraphs are very crowded. So I want to emphasize, if you have several paragraphs, you need to add some spacing to the paragraphs, between paragraphs. Or at least you can use indentation. Indentation or spacing. So this will be the last time I'm emphasizing this elegant thing. But in the next time, this 0.5 point will be taken out if it doesn't meet the lowest criteria, lowest level. Okay, now let's go to the lecture review. Everything in the homework will not be tested. Everything you have already written in your homework will not be tested. At least will not be tested directly. So the notes you made have nothing to do with the exam. Now it's the starting of reviewing the lecture. I have listed 5 pages of possible questions, and if you understand the answers to these questions, that will be enough preparation for the midterm. So I'm presenting to you the questions one by one. The first question is, why do we need traffic simulation? And in the first lecture, I said I will leave this question to you. And now I'm still leaving this question to you. But I will tell you what I think. What I think is not the standard answer. So don't repeat what I said. The reason that we need traffic simulation is not because now it can help you do something. Currently, it's not a very strong tool, I think. It's still very weak. It has a lot of weaknesses. The reason we need it is because its potential in the future. So maybe in 10 years or 20 years, you will become a tool that can really be used. So currently, if you create a simulation model, it may take you half a year, and the result may be very bad. And when you change any part of the network, you have to build it from scratch, or you have to spend a lot of time modifying it. And that's the reason I want to spend some time to advance its current state of the art. So my answer is, it may not be very useful for you now, but it may be very useful for you in 10 years or 20 years. The next question, what's the simplest way to show higher statistical significance? Remember, you have a lot of data and you perform this significance test, and the result is not satisfying. What's the simplest way to show higher significance?
Increase the sample size.
Yes, yes, increase sample size. So statistical significance is a function of the number of points.
Can you give me some example about the weakness of traffic simulation?
Sure. Weakness of traffic simulation.
You say there's a lot of.
Yes, yes. The first thing is we don't have enough data. So when we collect the data for traffic simulation, sometimes we have to use formulas, sometimes we have to use existing models. And these data are not always not matched. So you get this piece of data in year 2000, another piece of data in year 2010 or 2005, and you then use factors to convert them. And I think you know that the traffic pattern each day is completely different. And we use some like Thursday, that's Tuesday to Thursday in a typical September, but that will not be accurate for every day. That will not represent the traffic status for the other day. And that was my complaint. So we don't have a very swift tool to develop these models, and we are not unable to use them for predicting the result in an online fashion or real-time fashion. And then why do we need that? So there is no real application, that we can use the traffic simulation. When we do planning, we don't need a movement of each vehicle. We only need the macroscopic view of the traffic system. So I think currently the only reason we are using traffic simulation is because we want to generate some visualizations, so the public can understand our project better. But when we use that for designing, it doesn't have any real advantage. But that's my personal opinion. So the next question is, what is the law of large numbers? I think it's a very standard question. You can find the answer from everywhere. I just want to emphasize the prerequisite of law of large numbers. So it doesn't mean when you have large numbers, you have a law. The assumption of the law of large numbers is that all of these random variables are already following a distribution. And this distribution will have a mean. Then the more random variables you